Hello, all of you. We are going to study this course, data warehousing and mining. We are going to start with our chapter number one of this data warehousing and mining course. In this chapter, we are going to cover various topics, which includes data warehouse, basic concepts. We'll be discussing about it, data warehouse modeling. In that, we are going to discuss in more detail about data cube and OLAP, data warehouse design and usage, data warehouse implementation, data generalization by attribute oriented induction, and a quick summary of this. So let's proceed with data warehouse. What do you mean by a data warehouse? So we all know the definition of data. Data is basically of two types, structured data and unstructured data. So you all are familiar with this database management systems in that you are supposed to create a relational tables. So relational tables is an example of your sorted data or structured data that you can say. So data warehouse, so it is defined in many different ways. Okay, so it can be a decision support database that is maintained separately from the organization's operational database. It supports information processing by providing a solid platform of consolidated historical data for analysis. Now, the technical definition of a data warehouse is: a data warehouse is a subject oriented, integrated, time variant, and non volatile collection of data in support of management's decision making process. This was termed by W.H. Inman. So we were discussing about data warehouse. So data can be a structured data, unstructured data. You also have taken some of the example of how do you basically convert an unstructured data into a structured data. So coming to our subject, data warehousing and mining. So here we are going to start with the topic data warehouse today. So the definition says that a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. So we'll see this. So remember that a data warehouse is composed of these four keywords, which you have to remember. It is a subject-oriented, it is integrated, time-variant, and non-volatile collection of data for non-volatile collection of data in support of management's decision-making process. Okay, so let us start one by one. A data warehouse is subject-oriented. So, uh, so it is organized around several subjects. For example, it can it can be focused on customer, product, or sales. So it is subject oriented. So focusing on the modeling and analysis of data for decision makers, not on daily operations or transaction processing. Here we are focusing on the analysis of data for decision makers. So yeah, it provides a simple and concise view around particular subject issues by excluding the data that are not useful in the decision support process. Now, the definition also says that data warehouse is integrated. So it is constructed by integrating multiple heterogeneous data sources, which various uh, sources of data can be, it can be a file format, it can be a macro file, for example, a Word document or Excel file. It can be .csv file. Data can be stored in the form of flat files, online transaction records, relational databases, and so on. So this data warehouse is integrated. It fetches or collects the information on several different heterogeneous data sources. The next step after you collect the data is data cleaning and data integration techniques. So these techniques are applied, so which ensures the consistency in naming conventions, encoding the structures, attribute measures, etc. So for example, if you're having a data about a hotel, which includes the hotel price. Hotel price is composed of currency, tax, breakfast covered, etc. So you so there are different sources of data, but you need to integrate the one which is relevant for you at that very moment. So here the data is moved to the warehouse and it is converted. Next keyword is time variant. Data warehouse is time variant. So which means that yeah, let us see here. The operational data, our operational databases collects the value data, the current data or the value data. But when you check with the data of a warehouse, data warehouse provides information from historical perspective. So it gives you historical data which can be past 5 or 10 years older, or 20 or 30 years older data. So here every key structure in the data warehouse contains an element of time, explicitly or implicitly, but the key of operational data may or may not contain time element. Now, data warehouse is non-volatile. So, a physically separate store of data transformed from the operational environment. Operational update of data does not occur in the data warehouse environment. It does not require transaction processing, recovery, and concurrency control mechanisms. Here, in this case, data warehouse is non-volatile means there are only two operations which are used in data accessing. That includes initial loading of data and access of data. So that's it for today's lecture. In the next lecture, we will see about OLTP and OLAP.